everyone, a very good afternoon. I would like to thank you all for joining us today. My name is Aparna Haldar and I'll be hosting this webinar. Before we get started, please let me take a few minutes to introduce Payatu. Payatu is a research-powered cybersecurity consulting firm. We have a decade-long track record with a singular focus on cybersecurity. The foundation of Payatu rests upon three pillars: community and conferences, consulting and training, products. Community and conferences encompass NullCon, an international security conference, training, and exhibition platform, Hardware.io, a hardware security focused conference, along with other initiatives. Consulting and training focuses on thorough security assessments, which helps businesses to discover security threats and further provide training to strengthen network infrastructure. Lastly, we have three offerings: IoT Auditor, an IoT security testing and compliance platform; Exploity, an open source IoT security testing framework; CloudFirst, an automated and highly scalable first testing platform. Here is an overview of the various consulting assessments we are known for across the globe. Payatu has delivered many cyber talks and workshops in top security conferences that also include Black Hat and DEF CON. We take pride in the decade-long impact we have created by contributing to the cybersecurity community all around the world. That was all about Payatu. Today, Kedar Sovani, a Senior Director of Engineering of Espressif Systems, will deliver a webinar on security and privacy in the smart home with Matter. You can read all about him on this slide. Espressif Systems is a public multinational fabless semiconductor company focused on developing cutting-edge wireless communication, low-power AIoT solutions. They have created the popular ESP8266, 32, 32S, 32C, and 32H series of chips, modules, and development boards. By leveraging wireless computing, Espressif provides green, versatile, and cost-effective chipsets. Before I hand it over to Kedar, I request you all to follow a few housekeeping tips. Please be on mute. If you have a question, you can write it in the chat box. We'll answer the questions during the intervals or at the end of the webinar. We'll be releasing the recording of this webinar on our digital channels. So make sure you're following Payatu. If you're not currently following Payatu, please check the links provided in the chat box to find Payatu's digital channels. Without further ado, let's get started. Kedar, over to you.
Thanks, Aparna, for the introduction. Hi, everyone. Good afternoon, good morning, or good evening to wherever you are. And thanks, Aparna, for inviting me here to talk about security in Matter. Today, I will talk about security and privacy in the new smart home standard, which is Matter. I think many of you might have already heard bits and pieces about Matter here and there, but for those that are uninitiated, Matter is a globally unifying standard for smart home that has been introduced. It is expected to be a unified framework for the connected things. Importantly, there are biggest, largest organizations of the world that have been participating in this industry, be it the IoT industry or the high-tech community, is part of this alliance. And everybody realized that so far the kind of experience that end users were having as far as IoT is concerned was very fragmented, and hence everybody came together to define one standard which encompasses most of the common concerns and provide seamless solutions that provide a very rich user experience to the users of these technologies. And that's how Matter has been born. Given that it is a collaborative effort between such a large and wide participation across the high-tech industry, it has been everybody's goal to make this standard the best of what is possible in terms of the kind of features that it offers, the security that it offers, the kind of benefits that it offers to everybody. So that's a little bit about Matter. And additionally, just to provide some more context, Matter is an application level protocol. It assumes IP-based networking, and runs on top of the TCP or the UDP transport layer. At the transports or the MAC layers that are available today, it works on Ethernet, Wi-Fi, as well as Thread, which runs on the 802.15.4 protocol. So those are the protocols on which it is expected to run, and this matter runs on these protocols. At the same time, the commissioning part, where the device is first time configured, that happens on Bluetooth Low Energy. So that aspect is offloaded to BLE, and then all the rest of the communication can happen either on Ethernet, Wi-Fi, or Thread. All of those three fairly well suited for the smart home. So one of the things that always comes to mind when everybody talks about this is that, what does matter mean to me? Why should I be concerned about it? How does it affect me? And I think there are two helpful ways to look at this, right? One is as an end user. What is it that it is offering the end users, right? One, it is offering end users no more silos. Previously, we've seen a number of cases where you have to open a phone application, and that application only works with its set of devices. And then, if you have a bulb, it has its own app, and a fan has its own app. Then it's very siloed from that perspective. And the fun of IoT happens when devices seamlessly talk to each other, right? So all of that kind of is taken away when you have all these silos. With Matter, we expect that all of these silos go away, and there's a uniform way of communicating and talking with all of these connected devices. Second is more automations. Matter expects, or Matter proposes, that devices can also talk to each other directly. So you can have a sensor, occupancy sensor, and a bulb that can directly talk to each other with no intermediary in between. You need not need a skill or a phone app or any kind of a cloud to manage this kind of a communication. And whenever I talk to people and I tell them about this, they're blown away. They're like, hey, because so far everybody, such kind of integrations happen either through cloud mediation or phone app mediation or some kind of a voice skill mediation. None of this is required, and devices can talk with each other seamlessly, which is an important part of it. Finally, it works on multiple transports. As I mentioned, it works on Wi-Fi, Ethernet, and Thread. But an interesting thing here is that the devices from one transport can even talk to devices on the other transport. So you can have a thread-based sensor talking to a Wi-Fi based light bulb completely over Matter without any intermediary involved as well, which really helps you as a consumer or end user pick the best components that you want to have based on the needs that you have, without worrying about whether this is compatible with the other components. As long as it's a Matter compliant device, it will just work very nicely with any other Matter devices that are out there, right? And then finally, better security. Because this is, as I said, whenever we buy solutions, especially connected solutions, there's questions about what is the kind level of security that these devices will have, and what are the kind of compliances and conformances that the device obeys. Given that a lot of things are baked into the standard itself, as an end user, you can rest in, you can be in peace that, okay, security is already taken care of because it's part of the standard and it's baked into the processes that are part of this, right? This is what it means from an end user perspective. From a device maker perspective, what does it mean? It means ease of development. I have seen a number of device makers who have to really struggle because there are multiple ecosystems, and you have to spend time making sure that your device works with multiple ecosystems. It works with iOS, Android, and other ecosystems. There are multiple certifications that you have to do. Voice assistant skill integration is a separate effort. So there's a lot of effort that goes into it to make one fully functional IoT device. Because Matter is a unifying standard, it helps that you just build one device and everything will just work with it out of the box. So support for Matter is already part of iOS. So all the iPhone or iPad or users can directly natively the operating system itself supports communicating with these kind of devices. The support is available on Android phones also. The support is available on voice assistants like Alexa, Google voice assistants, and others. Support with the Samsung ecosystem. So a number of ecosystem players have already supported this, and today you have functioning products that can work with any of these things, and all that the device maker has to do is build a product for Matter. And once it built for Matter, it works seamlessly across all of these ecosystems. So it's a significant benefit for device makers. Second, it's power of open, because the SDK is openly available right now. You can go to the SDK, download it, execute it on one of the embedded development kits that are available, and experience it even today, no questions asked, right? So it's open. You can start working with it. You can understand what it is and how you can envision your products with it. Device-to-device automations, as I mentioned, where devices can directly communicate with each other and provide additional functionality, is a big part of Matter. But I think one important aspect is that if you are a maker of, let's say, sensors, some kind of sensors or some kind of actuators, previously you had to be part of an ecosystem, because if you have a smart sensor, how will it help unless it connects with something else and control something else? So now you have to package it and create a package solution that customers buy in one go. With Matter, as long as you are Matter compliant, you don't know which other device it will be able to control or connect, but it doesn't matter. It's up to the user how they make the connection. You just build the sensor and it'll just work out of the box with any other device that is out there. So that's about the device-to-device automations. And finally, innovation. You as a manufacturer, you as a maker want to showcase your unique features or unique innovations that you bring to the device type. And those are easily supportable in Matter, which helps you differentiate yourself and set yourself apart. So having said that, that's a short introduction about Matter. Now we look at Matter from the lens of privacy and security. As far as privacy is concerned, these are some of the common underlying principles that are expected to be obeyed as far as user data privacy is concerned. From a security standpoint, also, the following principles are core to Matter's development. Right, one is comprehensive. It is expected that the security is comprehensive. It is present in a multi-layer approach. So every layer takes care of its security. At the same time, the security is self-contained in the sense that, so for example, the Matter as a protocol completely defines its own security. Even if your transport protocol, let's say you're working on an open Wi-Fi network, so it does not rely on the security of the transport layer, but it has defined mechanisms where it is self-contained within the Matter layer itself, right? Secondly, strong, and by that I mean state of the art. All the cryptographic algorithms that have been used adhere to the best possible standards, and the regulations comply for any civilian devices that should be available out there. Ease of use. As we bring security, we want to make sure that it is not extremely hard for an end user to use it, otherwise it's not very helpful. At the same time, it should be very easy for device makers to build the product also. They don't have to jump through hoops to build the product. And that has been a core principle behind Matter. Resilient. So the security has to protect the device. At the same time, it has to detect issues, and then it should be able to recover from those issues. That has been a principle. And finally, agile in terms of crypto flexibility. All the crypto algorithms and standards that are used as a component, they can be changed to newer, more mature variants as the landscape evolves, without affecting the functionality that the protocol exposes or offers to the users. So these have been certain security principles that are part of the standard. Now, what we will do is look at different facets of the Matter standard using the lens of privacy and security. To begin with, let's talk a little bit about the spec and implementation. As a spec, I mentioned that it works over Ethernet, Wi-Fi, or Thread. The spec in itself is completely local network based. So it assumes, it does not have any, as we talked about in the device automations, it does not assume that a cloud is in picture or something else is in picture. It just assumes that devices are part of a particular network. It could be a Wi-Fi network, Ethernet network, or a thread network. And it exposes all the features and functionality it offers within the devices in this network itself. This is especially important for people who are very privacy conscious and who want to make sure that their data does not leave the bounds or the threshold of their home. And this becomes a very big attraction point for them. As you can see, the devices that communicate with each other, or the phones or any other nodes that communicate with these devices, completely communicate over the local network. Secondly, the implementation is open source, as I mentioned, and it is available on GitHub. It is peer reviewed. But the most important part is that there have been many standards that are defined as specs, but then different vendors provide implementations for these standards. And what ends up happening normally is that then these implementations have certain differences, right? And then bugs lurk in these hidden assumptions. One benefit of the implementation available on GitHub and universally contributed by most of the members of the Alliance is that there's a single implementation which is peer reviewed, and hence it has very strong reviews. At the same time, if any issue gets discovered or any issues are identified, then they get updated in that single location itself, and thus are universally available for all the other devices that support Matter. This is a very big part of this is a very big part, because many times issues have been identified, but it might take much longer for the individual implementations to catch up with the issues and then eventually roll them out in the devices. Having a single implementation helps it tremendously from that perspective as well. Finally, the implementation, as I said, is open and interoperable, but you can deploy it today on any device of your choice. For example, especially for people who are privacy conscious, they might have certain devices in their house. Let's say you have a Raspberry Pi in your house or a Linux machine on your house, or a Mac. You can download this implementation and you can use that Raspberry Pi or your Linux device or your Mac device as a controller that controls all the other Matter devices in your house as well. And it becomes a completely part of your local network with no information going out, because this is completely available to you. The devices that will be Matter devices that are available in the market will work seamlessly with this controller that you have set up on your Raspberry Pi, and you'll be able to control it and manage it completely through that, which goes to a great length to talk about some of the benefits, especially for folks who are very cautious about the data, especially their personal data. So these are some of the parts as far as the spec and implementation is concerned. Now, we'll look at certain workflows of Matter and identify how security is baked into some of those workloads. We'll assume that we just got a device, which is a Matter certified device. We just bought the device. Let's imagine that this is a bulb, let's say, and we bought a Matter enabled bulb and we brought it in the house, right? And now we want to start working with this bulb. So one of the first things that the Matter protocols proposes is a method, something called device attestation. This is where the device has to prove that it is a genuine Matter certified device. And the way this is managed is that each device, which is a Matter certified device, must have a unique certificate programmed into it. So if you have 1 million devices, you'll have 1 million unique certificates that will be programmed in each of these devices. Finally, there's a global distributed compliance ledger, and it has a list of CAs, which are the trusted certificate authorities. So whenever a device comes in your house, and let's say I'm trying to commission that device or onboard this bulb into my network, and I'm using my iPhone to do this, then the iPhone can go to this compliance ledger, get a list of these trusted CA certificates, and make sure that this device is a valid device, which is a genuine Matter device. And I've explained it a little bit here using this diagram. So if you see, you have two devices, device 1 and device 2, and both of them will have certain certificates. In the matter parlance, they are called device attestation certificate. So DAC1, DAC1, and DAC2. The commissioner, in this case, the iPhone, as I'm adding this device to my network, during the commissioning process, it will fetch this certificate from the phone, and then it will validate from this compliance ledger. The compliance ledger is an open ledger which is available, distributed compliance ledger, and it will have a list of all the CAs that are trusted CAs. So it essentially uses a similar mechanism that our websites use for trusting the website, right? Where using the PKI and certificate chains, we validate that the website is really the website that we are talking to. Similarly, in this case, the commissioner validates that this device 1 really is a device which is a genuine matter device. And let's say if we bought it from certain vendor X, then the certificate should also say that the device really is from vendor X. How the DACs are generated is also defined in terms of entities that are trusted get their CAs listed in this ledger, and then they are authorized to grant these DACs or device attestation certificates to vendors who can then take and encode these into their devices. That's how the device attestation process works. And this is the first step which guarantees that the device that you bring in your house is a genuine matter device. Now, the next step is the proof of possession based onboarding. This is a sample QR code that every matter device that you have will have. This, again, is unique per device. If I have 2 light bulbs, they'll have their own different QR codes on their packaging, on their box, on the device. This ensures that whoever is commissioning the device, they have the proof of possession. They can prove that they really own the device because they have access to this unique QR code that is part of the device. And only then this is validated. So the device validates that the whoever is commissioning the device has access to this QR code, and hence they really own this device. So there have been certain attacks where your neighbors commissioned your devices without you even knowing about it. No longer happen because you have to prove that you have the possession of the device, and the QR code is part of that. This particular protocol, the SPAKE2+ protocol, is an augmented PAKE protocol that is used for session establishment during this commissioning phase. I'll talk about a number of crypto protocols and mechanisms here for those who are more inclined into understanding the details about it. The spec for matter is available. You can go to the website, register for it, and get the specification. If you even go to the GitHub repository and go to the source crypto directory, it'll have implementations of these protocols, and the implementations for OpenSSL and Embed TLS, primarily cryptos using OpenSSL and Embed TLS, are available, and you can go look at that as well. So this is where the device commissioning process begins, where you use the QR code and then start the process. Once the process is started, you can commission the network credentials into the device. So if it is a Wi-Fi bulb, then I bring that bulb on the Wi-Fi network. If it's a thread bulb, then the device becomes part of my thread network. So once the device becomes part of the network, how do you identify this device? That is where we call it the device operation, and that is where an operational certificate is issued to the device. So this is a certificate that is issued by the commissioner. So if I'm the iPhone, then I provide the device with an operational certificate. And this is a elliptic curve SECP256R1 curve based certificate that is issued to the device. So in this particular case, I'm saying this is the certificate that I issue to this device. And it says that this device has this node ID, which is XYZ, and it is signed by something, say org1. And then at the same time, I also provide the device with the certificate, the root certificate of the org1. Because of this, the device gets a unique identity using this certificate. At the same time, the device gets a CA that it can use to validate other certificates. We talked about device to device communication, right? Where the bulb can communicate with a sensor, or even when this phone app is communicating with this bulb. First, they make sure that these certificates that both of them have been signed by a common root CA. And only then they trust each other because their identities have thus been validated. As you can see, that even the local network communication that begins through this particular step. So PKI is baked right throughout the process, right from commissioning to device operations. One of the side effects of using this kind of a mechanism is that Matter also supports multiple logical networks within one physical network. So although you have one physical Wi-Fi network, you can create logical networks where devices in that network cannot understand or communicate or do not know about this other Matter network that is available. And this is a little bit of that. And let me, the diagram looks a little bit complex, but it's not as much. So let's say this is a bulb, right? Then this bulb has two operational certificates in this particular case. It has an identity XYZ in org1, and this is the org1, let's say. And it has an identity PQR in org2, and let's say this is the org2. And then all other devices in that organization will have their own certificate, will have their own node ID, and those certificates will be signed by the same root CA. In this case, we call it org1. And in this case, they are signed by org2. At the same time, one device can be part of multiple of these organizations also. So for example, for this phone or this switch, they are only part of one logical network, so to speak, and which is this network, which is the org1. At the same time, this bulb is part of two logical networks at the same time, org2 as well as org1. What this does is allows you as a user great control. For example, for IoT devices, a number of times people felt that, hey, I have an Android and my wife has an iPhone, and maybe my kids prefer Alexa or something like that. And will we all be able to interact with the device? And this is definitely possible, right? Because each of these can create their own logical realms or networks within the Wi-Fi or thread network that you have. At the same time, you can have devices that participate in multiple of these networks also. This gives you a great power because now you can define how you want to structure this network, especially for a home. You can have all devices be part of all of these sub networks as well, so that they work seamlessly with each other. Or you could say that I have a separate organization for sensitive devices like door locks, which are restricted to a couple of users, and then the others are part of a separate logical network completely as well. So this is a very powerful feature that allows devices to be part of multiple of these networks, and we call them ecosystems. So these are ecosystems. It can be part of different ecosystems. Now we are at a stage where the Wi-Fi light bulb is part of your network. It has been given an operational certificate, and because of the operational certificate, it can prove its identity to other entities in the network. Once that happens, whenever it communicates with any other device, or whenever your phone or your voice assistant communicates with your device, a Sigma-based session establishment is used. ECDH is used for exchanging keys and deriving shared secrets, and then the actual communication that happens using AEAD AES-CCM 128. This ensures the confidentiality and integrity of the session data. So any communication that now happens between two entities on the same network, two Matter entities, be it the phone and the device, or between two devices, happens using over a session, and the session will have its own keys, and it will ensure that the data that is exchanged between this session is encrypted using AEAD AES-CCM 128. It ensures that any other entities of that network or even that particular logical network have no visibility into what is the kind of communication that happens between the two nodes. This is as far as the device operations is concerned. We talked about node identifiers earlier, where we said that this has node, this is node XYZ, and this is node ABC. These node identifiers are completely random, and importantly, optionally, you can even have encryptions for these identifiers. So if somebody is on the network, then you know that whenever packets are exchanged on the network, there is some parts which are plain text parts, and then some parts which are encrypted parts. What this does is that it also has another layer of encryption for the identifiers, so that if you have entities on the local network who are trying to understand which device is which device, or trying to gather that point of data, that is also not possible given this privacy encryption based feature. This helps it go enhance the privacy one step further, where even the identifiers are encrypted, so anybody on the network has very, very limited visibility in terms of what is going on. Finally, there are access control lists. Now, so if we look at the journey so far, we got a Wi-Fi light bulb. We validated that it's a genuine Matter device. We used the QR code to bring that bulb on my Wi-Fi network. We gave it an operational certificates. When I opened the session, the operational certificates were validated by both the ends. And then a secure session was established, and the communication is now encrypted over AES CCM 128, right? Once all of this happens, the next level is the access control lists. Every device, you can define certain access control lists. The default is deny. So if an ACL is not defined, then no operation is possible. If my phone is trying to access the device, then somebody should have explicitly configured an ACL on the device, which grants me the access to this particular device. Now, ACLs can be fairly fine-grained. It can tell you which clusters, attributes, and commands you can talk about. I'll talk a little bit about what these are, the targets, but essentially you can think of it as it can limit the kind of things that you can do on the device, maybe the kind of actions that you can take on the device. Then the ACLs define the actors. So it can, an ACL can say that my wife's phone is allowed to do certain things and my kids' phones are allowed to do certain things. And it also has a privilege level. So you can say that this particular phone or this particular identity can have operate privilege or manage privilege or administer privilege. So even beyond that, once the session is established, it'll try to make sure that the ACL, there's an ACL on the device that allows the node to take that particular action, and only then access is granted. Finally, to be more expressive, wildcards are also available in the ACL, so that you can define groups, or you can define wildcards and provide access based on that. So it's a fairly comprehensive feature that allows you greater control on the kind of accesses that you grant for the devices in your home. Now, this is as far as the security and the privacy features are concerned. Now, let's take a quick look at the data model. From a pure security standpoint, the data model is, it's additional information, but from a completeness perspective, I thought it is helpful to have it here. And these are some of the terminologies that Matter uses. So in the case of Matter, there's a node. So if you have, since we talked about the bulb is like a node, and it has endpoints. So one bulb can have, one device can have multiple sub or logical devices. So in this case, maybe I have two bulbs. My one fixture can have two bulbs. One of it is dimmable and one of it is not dimmable. So it's just an on-off light, and one is a dimmable light. And then subsequently, there are some things called servers that cluster certain information. Now, in this case, if we just look at this part, which is much easier, I'm saying that my device has an on-off cluster server, and it responds to the commands on, off, and toggle. This is the data model, so that anybody that can speak on, off, and toggle can issue these commands on my device here, right? And this is my dimmable light device. So additionally, apart from the on-off toggle, it has a move to level feature also, because now I can control the brightness of the device to whatever I want, right? And then maybe in some cases, I could have a color light, in which case I would have an on-off toggle and maybe a brightness. And additionally, there will be another cluster, which is a color control cluster also. And then you can configure the color of the device as well. So this is how a matter device at the data model layer. So after we've looked at all of these security layers, and after the ACL is granted, and when communication happens for these attributes and commands, right? And this is a quick example of how this works. So if we look at this being a bulb, which is controlled by a dimmer switch and let's say a toggle switch, then the servers that we talked about, this has two servers. It has an on-off cluster server and a level cluster server. So this is used to do on-off. And whenever I toggle the switch, it has an on-off client, which sends on-off or toggle commands to the device, and the device can switch on or off. But similarly, it has a level control cluster, which can be used for dimming. And hence a dimmer switch that you might have in your house can also send it dimming commands like move to current level or move away from current level. And that's how it can do the dimming operation as well. So anyway, this is as I said, I included this piece here just to provide a completeness from a matter perspective. But this is how the entire matter stack operates, or the matter device operates from the user workflow perspective, as far as right from bringing the device home to controlling the device using any of the entities, and the possible configurations that you can do to communicate with the device. So finally, we come to platform security. Now, as we talk about devices, there are multiple different security concepts that platforms provide them. Typically, these devices work on MCU-based systems or tiny embedded Linux-based systems. So platform security is left up to the device makers to make the right choice or the best possible choice of the platform that they want to implement for the kind of device that they have. So locks, you might want to have a much higher level of security and should have a tamper-proof, physically tamper-proof hardware. As a manufacturer, you can make use of the best platform security concepts that are available out there. For most of the cases, a trusted boot or secure boot-based mechanism with secure enclaves or ensuring that the private keys that are exchanged, the operational credentials or the private keys for the DACs are protected and have the highest level of protection is recommended. And this is, again, as I mentioned, it's for the vendors to identify the best platforms for the solutions that they would have. So with that, I complete the discussion that I intended to talk about, which is the security and privacy in the Matter protocol. And then I leave with the security principles that we talked about, comprehensive, as we looked at the different layers in which security is provided by the Matter protocol, some of the crypto cipher suits that are the state-of-the-art cipher suits for the kind of devices that we looked at, the ease of implementation that comes from having this common implementation that is available for everybody to quickly use, and then the resiliency and the agility that is part of the spec. With that, I conclude my session, and then Aparna, if there's any questions, we can take those.
All right, Kedar. So, guys, the session is open for the Q&A. Anybody have any questions, please drop your questions in the chat box. Kunal says it is a very knowledgeable session and he's very thankful about it. So there's one question. Kedar, what is a typical use case for the access control list?
So you can think of access control. If you look at the sharing feature, device sharing feature, the access control list is a very good way to use that. So for example, I want to have, as we talked about certain devices, right? I want to be able to share a device, let's say with my wife's phone, so that she can communicate with that phone and her identity essentially with that device. At the same time, I also want to share it with the kids, but I don't want my kids to have the entire control. So I can give an administrator based privilege to my wife, but for my kids, I can only give a view based privilege or an operator based privilege. So there are different levels of privileges that are defined in the standard, and I can choose as which entity I can give what kind of a privilege. And this depends upon the kind of device that I have. For a bulb, maybe I don't care as much, but for other devices, I'd be much more sensitive. And then I can define how I want to expose certain device to certain users without I granting an access control explicitly to the user will not have access to that particular device. I need to explicitly give access using these access control lists. And in this case, meaning the entity who first commissioned the device on the network. Okay, that's great. Thanks, Francisco.
And the next question is, can we write customer cluster?
Custom cluster. Custom clusters, yes, you can write custom clusters. So you can, for existing clusters, you can write custom commands. If it is entirely possible for you to write custom clusters also. Both of those things are possible. Just a note that as you write custom clusters, the other end should also be aware of it. So then it assumes that you have the other end. So for example, if you write a custom cluster on the bulb, which exposes some unique feature or functionality, then I make sure that that unique functionality is available in the app that I write. So there is certain baseline functionality that is already part of the clusters, and then any innovation I do on top, you just make sure that it is understood by the other end, the clients also, so that they can control it and make the best use of
it. Next question. How can one define access control list from the app, which is not default app of the device, like define ACL in Google app for Wipro Lite?
Right. So this is it's a good question. So basically, because this is part of the Matter standard itself, any app which is a Matter compatible app will be able to define access control lists for your devices as long as that app has access to the device. So for example, I got a Matter based bulb, and if I have an app which is a Matter compliant app, then it already knows how to configure access control on my device, because it is going to talk Matter protocol and the device is going to go talk Matter protocol. As long as the app or the node ID of the app is authorized to add access control, because adding ACL is also a permission that needs to be given. As long as the app has that permission, we'll be able to add ACLs from any Matter compliant app to any Matter compliant device. I hope that answers your question, Vivek.
Is only the Matter standard available for IoT?
Yes, it's primarily done with devices in mind. So it particularly assumes that, and it is optimized for these resource constrained kind of devices. And the kind of workflows that are there are also assumed to be specific to the devices. And while we start with a set of devices initially, I think over a period of time, more and more number of devices will get part of the Matter standard itself.
Since there's no controlling mechanism, server or cloud, how does a device get qualified as a controller?
So as I mentioned, a controller is an entity that can execute the Matter side of things on the controller. And as I mentioned, so for example, today, if you take the GitHub repository, build it for some Linux machine, then your Linux machine can be a controller for the devices in your house, and it'll just start controlling all these devices, right? So that's how you can control these devices. What will more likely happen is that so Apple has their own controller in the iOS, and then Google will have it in Android, or phone makers will have their own controllers as part of their operating systems. Amazon will have their controllers as part of their voice assistants and other areas. So you will have controllers like this. At the same time, there could potentially also be virtual controllers, where you have a controller which is fully implemented in a phone app, and it is communicating with other devices in the cloud. As long as the controller and the device are in the same network, there is no hindrance in having this communication possible.
If Matter supported natively on iOS, then why Apple Home app need a bridge like HomePod to onboard Matter device?
That's
Regarding,
a very certainly. So I think that's a very good question, Naresh. And I think the way it works is that for some reason, or for the Apple made a choice to expose this functionality through the HomePod, and tied it with the iOS, most likely to offer a better user experience, or also have Thread devices be part of the network, because Thread out of the a phone out of the box does not support Thread. But I don't know. I mean, this is a decision that every ecosystem vendor will make based on the kind of experiences that they want to offer. But yeah, it's an interesting question.
regarding customer cluster, again, the custom cluster need to publish publicly. And regarding
I
mobile
don't. Yeah, so
distribution,
I don't
can
think.
Mhm.
Right.
Oh, please go
Right.
ahead,
So
please.
as far as publishing custom cluster is concerned, I don't think you need to publish a custom cluster publicly. If you have some cluster which is available and then your device just talks to it, I think that should be okay. You don't have to publish it publicly. As far as phone apps is concerned, this is something that I need to cross verify, because there's already like app stores have their own certification. I don't know what the latest is, but I will get back to you on this one, as in terms of whether the phone app itself needs a separate CSA certification, or is the certification from the Play Store sufficient.
Regarding mobile app distribution, can we distribute mobile app without CSA certification?
Yeah, so I already talked on that one.
All right.
I just answered that one.
Okay.
Then can the Matter framework be applied for automotive applications? Possibly. So essentially, from the Matter framework perspective, as if there is an access point for Wi-Fi, or if there is a thread network available, then it should be okay, and it can work out of the box for those devices, right? So as long as from an automotive scenario, I think so. I'm not much aware from an automotive perspective, but as long as the baseline networks are available, then this communication is possible in those situations.
Why I need BLE profile from Apple to control device where I can bypass Apple HomePod?
Yeah, so this is a specific question. I will have to get back to you on that. I'm not sure I understand it completely. Why need BLE profile from Apple? So I'm not sure exactly what this means. But talking about your second question there, where the iOS does not allow direct phone to device communication, which is why I said for your previous question that I'll get back to you, because there's two parts to it. Either you're using the native iOS framework that is available for Matter, and the phone app directly uses that, or it directly uses certain mechanisms within the protocol to like for example, directly doing MDNS discovery from the app itself instead of using the iOS API. So I'm not clear what part of that is allowed by iOS and what part is not. It's a very ecosystem specific question that I'll have to check and get back to you.
Any more questions? Is Matter onboarding specific to a commissioner?
So if I understand this question correctly, yes, in the sense that if I'm a commissioner and I onboard a bulb, then the bulb has, and so if I'm a commissioner, I have a Matter node ID, and the bulb will have a Matter node ID, and the bulb will have a default ACL configuration which says that only my node ID is allowed to communicate with that particular bulb, right? So if I want to have a second commissioner to communicate with it, then it does not have to do commissioning, but I can grant it an ACL, and then it can control the device, which is the example that I mentioned. So I can have my wife's phone, which is essentially another Matter node ID, and I can configure the ACL on the bulb, which says that you can also be managed or administered using this other phone, which has a different node ID, and that will work without having to use the multi-admin feature. So you can have multiple different Matter nodes that can administer one device without them having to always do the commissioning. Yeah, so I think Naresh, you've already used parts of the Matter protocol because you're aware of the opening of the pairing window and such, and we should probably have a separate conversation for this, because I don't know if others are because there's a fair bit of context that is available here, but essentially you don't necessarily so ACL doesn't require you to open pairing windows. You can directly configure ACLs. Pairing window opening only has to happen if you want to onboard a completely different Matter fabric on the device. But as long as it's the same Matter fabric, then you can assign ACLs to different entities within the same fabric.
Thanks, Kedar. Do you feel that big companies like Apple, Google, and Alexa will get upper hand in smaller player and will have access to the data about other vendor devices?
I think if you ask me, Matter is fairly disruptive in the sense that so far nothing like this has happened in the IoT industry, which is such a unifying standard. It presents opportunities for different people in different ways. I'm sure everybody is looking at this and trying to identify what is the best possible way in which they can benefit from this. What you mentioned here could be one view. There could be others who are considering, because anybody can define their own ecosystems, right? So it's not like only Apple, Google, or Amazon can, and they can define their own ecosystems using Matter and provide features out of those ecosystems that make them a more favored option for users to choose. So I think it is disruptive, and everybody's looking at it, trying to figure out what's the best way that they can leverage this to offer the best experience to users. So we'll have to see how this unfolds.
How reliable is MQTT protocol in case of a security of a communication for smart home applications?
So Harshal, this is not technically relevant to the topic under discussion, so maybe we can discuss that separately. It's not related to Matter in a way right now.
For DCL compliance ledger validation, so Matter onboarding required internet on phone.
It is not necessary, because this is it's a trusted CA list. It can be downloaded separate earlier also. So at the time of commissioning, you don't necessarily need that list, and you can just go with it. So I don't think you need an active internet connection from that point of view.
Thanks. When can we have more session about Matter and topics around it?
Yeah, I'm always excited to talk about matter and interact with people because, as I said, this it's so new and everybody is trying to. There's different use cases. When I talk to people, different use cases come to mind which I have not thought about, and people are thinking about different ways in which they can use this to provide a significant benefit to customers. So it's very exciting time to talk about this and identify how everybody's thinking and trying to, provide a better story or better solution to everybody involved. So yeah, always excited to talk about it.
How to upgrade existing on-field device to Matter?
I think upgrading existing on-field devices to Matter should be so essentially there are two things that you need from the Matter perspective, right? One, you need this unique device attestation certificate to be part of each device, and second is that you need the unique QR code that should be present for the device to be commissioned. If you have an existing field on the device and you have presumably you have some mechanism to communicate with upgrade the device because it talks to the cloud, and through the upgrade, if somehow you can get these two unique pieces of information on the device, then your device can be upgraded to a Matter device. And again, this is very subjective because depends upon how your implementation of the upgrade is and what is possible and what is not. But a number of companies are looking at how they can do this, and it is possible for a number of companies, because once you have identified these parts of it, then technically you can have everything that is required for Matter to be present on the device. So it's a separate conversation again. So I need to check. I don't know.
So I guess that's about it.
Okay,
It
all
was an
right.
amazing
So
session, Kedar.
absolutely, thanks, Aparna. And I think the questions were very, very insightful and interesting. So had fun.
Thank you so much, and thank you, participants, for being such an amazing audience, and thank you, Kedar, for such an amazing session. So at the end, I have some news that I would like to deliver. So we have launched a WhatsApp community, a place with the sole intention to help organizations with cybersecurity content. And the second exciting news that I have for you guys is that we have launched Expertise Academy, a place for people who want to start off their journey in the field of IoT security. If you want to know more about these particular about the two of them, you can click on the links provided in the chat box, both with the sole intention to educate everybody. Thank you so much, guys. Yeah, that's about it, and have a happy weekend.
Thanks, everyone. Have a good one.